Welcome to this video. Please watch in HD. We're going to learn about maximum and minimum slopes in the IB Physics 2016 curriculum, and we're going to do it in Excel. Okay, you did an experiment. You took a ball, you dropped it from 10 different heights. Every time you dropped it, you measured its rebound velocity. How fast does it bounce back up at you? Maybe it's a rubber ball, maybe it's not so rubbery, maybe it's like a steel ball that doesn't really rebound very much, but who knows what you used. Here's the data. Every height, you dropped it 3 times, and you recorded the 3 different repeated trials. Each of those values should have been identical, but because of random error, they fluctuate. So you take the average, and you get the uncertainty over the 3 trials. Now, the uncertainty in the 3 trials, you found using the max minus min over 2 method, the half-range method. So you used a formula in Excel to do that, and here it is. You copied it down. Then you took the log of all of your independent variable values, logged every height, you logged every average velocity. Why'd you do that? Because you looked at the raw data graph, and you said, I wonder if a power function fits this data. The log-log analysis tests for a power function. If the log-log graph is straight, you've got a power function. And hey, voila, this is a straight line, so you do have, in fact, a power function that fits the data from the experiment, the raw data. So what's the power of this function? The power is simply the slope of the log-log graph, 0.48. I'm deciding to round it to 0.5. My power is 0.5, that's the same as square rooting. So then I made a final function graph. I took my height values, and I square rooted every one. And my y-axis is just the rebound velocity. I included uncertainty, error bars, and I've got my function, my equation right there. This is like the golden egg, or the holy grail. This is what you wanted in the equation. I was trying to figure out, you were trying to figure out in this experiment, how is the rebound velocity related to the height? You found, hey, guess what? It's a square root function. So they're proportional, rebound velocity is proportional to the square root of height, because it's a straight line through the origin, this graph. Right? Through the origin, the y-intercept is basically 0. But this slope, 0.7463, it's not perfectly certain. It is uncertain because of the fact that these data points have error bars. So here's how we find that uncertainty. We do the max minus min over 2, which means you need a maximum slope line, and you also need a minimum slope line. So here's how we do that in Excel. First, you make a copy of your final function graph. I do that by clicking on the white space, and then I hit Control while holding my mouse. I hit Control. I let go of my mouse, I'm still holding Control. Now that I've got my copy there, I can let go of Control on the keyboard. And then you make this chart nice and big. Right, so you've got a little room to work. Make it nice and big. Okay, that's a little better. I'm going to click my trend line, and I know it's clicked because you see that dot at the end of the trend line? There's one on the other side too. I hit Delete, or you right-click and hit Delete. Then we hit the Insert tab between Home and Page Layout. We're going to click on a shape. Specifically, we'll choose the first option under Lines. So you click that, and now let's add a line. There it is, my maximum slope line. And let me add my minimum slope line too, using the same process while I'm at it. How's that? Let's see how I've done. The first thing we do is we imagine not just error bars, but error boxes. You'll have to just imagine them, but I'm actually going to show you what these look like. Every error bar has a horizontal, or every data point has horizontal error bars and vertical error bars. And when taken together, there's a box of space which kind of encompasses where the data point was. This data point could have been anywhere inside the box. So let me show you what those look like for all of the points. Okay, here they are. Now I've added in shapes to show them, but you'll just have to imagine them with your mind. So now the goal is to move around your maximum slope line. You can move it up and down, and also you can make it steeper or shallower. Move it around until it passes through all of the error bars. And you also want it to be as steep as possible. So let's see. Oops, this is bad because I'm missing a bunch of the boxes. So this is a little bit better. How's that? I think that's a pretty good job. That's my maximum slope line, and I'm going to make it nice and long so it covers like the entire area of the graph. That'll help me later on, all the way down to here. Now I'm going to make my minimum slope line nice and long, and I'm going to try and make it as shallow as possible. So this is bad because I'm missing this error box here. So let me make sure it passes through all the error bars. Whoops, I mean all of the error boxes. And that's pretty good, I think. Maybe I can move it up a little and then make it even shallower. Yeah. There we go. Okay. The next thing that we have to do is find the slope of both of these lines. First, let me take away the error boxes. To find the slope of these lines, and by the way, you see how I've named this graph maximum and minimum slopes? That's a good name. To find the slope of the lines, you need to see the grid lines. So let me click on my graph, and then I click this plus that shows up, and then I choose grid lines. It's already checked, and then I hit the arrow. And I want to choose all of them. I want primary, I want minor, I want major on the vertical and the horizontal axes. And now I'm going to hit insert, right? And I'm going to choose a shape. What shape will I use? I'll use a circle. And I click my circle, right? Oh, but it's not a circle. So you hold down shift, and that prevents you from making anything except a perfect circle. And then I'm going to, it automatically brings me to the Format tab, and then you see all these preload styles. I'm going to choose a style by clicking on this down arrow right there to show them all, and I'm going to choose the solid black circle. And this circle is what I will use to mark different spots where my line goes right through the grid lines. So for example, here's a great point that I'm going to use when finding the coordinates of my maximum slope line. I'll use that data point. Let me do that for other points on the lines. Okay, so I found another good data point right here where it goes directly through the grid line, and then I found these two data points for the minimum slope line. Now I have to figure out what the coordinates are for each and write that somewhere on the graph. So here's what I do. I hit insert, and then I choose shapes again. And then under basic shapes, the first choice that you see under basic shapes is this text box. So you click the text box, and then you click where you want to add it on the graph. Okay. Now it's crucial when you click, you see how my graph is selected right now? If you add the text box but the graph isn't selected, the text box won't be inside of your graph. So you click the graph first, then you do insert, shapes, text box, and you click somewhere in the graph. And then you do open close parentheses, and let's write down the coordinates for this data point. The x value is going to be 0.02, and the y value is going to be 0.140. And now I'm going to do that for all of the different data points that I have. I'm going to hold Control and click on my text box, and now I can just copy it over. I'm holding Control all this time. I'm just clicking and dragging, right, to add as many copies as I want, clicking and dragging. And now I'm going to go and add the correct value for each of these coordinates. In Word, you can introduce the next graph you're about to show. And I'm just saying I drew maximum and minimum slope lines into graph 4, which would be above, final function. And then I'm going to copy and paste, Control V, right? But when you do, you get this mess. So instead, paste it as a picture. You can right-click and choose Picture right here under Paste Options. It's the rightmost option you choose. Now, because my graph was massive in Excel, it's massive here, so I have to click on it and then make it a lot smaller. But if your graph is a reasonable size in Excel, this isn't a problem you have to worry about. Okay. And then I'm going to center it, Control E. And I'm going to go down here. Next, we're going to insert an equation. We'll introduce the equation. We're going to calculate the maximum and minimum slope from these coordinates shown. So here's my introduction. And then I'm going to show the calculation using the equation builder. So I hit Insert, and on the far right is Equation. And then I'm going to say, quotation, max slope, end quotation, and then I hit space, equals. I add a fraction next. and you click Design, Fraction, and the first option is what I like. Then I click into the numerator. I do y2 minus y1, but the 2 is a subscript, so I hit Design, Script, and then I choose the subscript option. Second choice. And oops, my y wasn't part of it, so I delete the y. I go in right here, y2 minus y1. And another way to get the subscript is to click the underscore button, so shift underscore on your keyboard. It's next to plus. Then you hit space over x2 minus x1. So after I typed 2, I hit space and then minus x underscore 1 space. Alright, now we need another fraction, so we can plug in values. So you can either do design and then fraction, or you can hit the divided by sign, / and then hit space. Next we plug in values into the formula. So this is y2, this is y1, this is x2 and x1, so I've plugged those values in. They have units, and you need to show the units in the sample calculation. So the units on the y-axis, that was speed, or velocity, and I should show velocity with the units here. So the units are meters, seconds, superscript, so I do shift caret, it's the 6 button, shift caret, meters per second to the -1, and then I hit space. And I'm going to copy this and paste it right there. What are the units on the x-axis? It's height to the 0.5, so the unit is, I'm going to unitalicize, meters to the 0.5. And then I copy and paste. And then I calculate the value. I get 1.04. These are my units, and these units simplify because the meters becomes meters to the 0.5. Do the same calculation for the minimum slope and include it. You don't have to show the sample calculation again because you've got one here, but you can if you'd like. Next we calculate the absolute uncertainty, and you introduce that. I'm using the equation builder again, and the delta symbol can be found under Design, and in all of these symbols here, it's the one shown on the second line near the middle. We plug in values, so I copy this, I paste it here, and then I subtract the minimum slope value, 0.57. It has the same units, so I copy and paste. On the bottom is just 2. You calculate the value, and I'm going to give this absolute uncertainty 2 sig figs rather than 1. The units are the same. Now, if we look back for a moment, we started out with 3 graphs: raw data, log-log, final function. We just found the uncertainty in the slope. But which slope? The answer is, it's the uncertainty in the slope of your final function. 0.748 comes from values that are uncertain. That's the slope for these data points. But every data point has uncertainty. So the slope value must have uncertainty too. And we just found how big it is, so we mentioned that. The slope of my power function is 0.748, and then we do plus or minus 0.23. But we have to round this to match the number of decimal places as the uncertainty, and the units are the same, meters to the 0.5, seconds to the -1. Or we can write this as a percentage. So I've got the same thing again, but this time I included the units next to the value. And the percentage is, I take 0.23, right? Except you use the unrounded value, 0.234, ... 285, and I'm going to divide that by the amount, 0.75, except I use the unrounded value, so 0.748, and I multiply by 100%, and I get 31%. So that's a pretty high percentage. But that's what it is, right? This percentage uncertainty in your slope tells you, in a way, how confident are you in this function. How confident are you that it fits your data? If it's a really big uncertainty, then you may not really have a very valid conclusion, or there might be some tenuous nature to your conclusion. That's why we get this value.